Welcome back, everybody, for another deep dive. Today we're looking at DeepSeek LLM.
Yeah.
It's a new family of open source large language models.
Right.
And we'll be taking a look at this research paper that goes into detail about them.
That's good.
These models are really interesting.
Yeah.
Not just because of how large they are,
Okay.
but because they challenge some assumptions about how AI learns best.
Yeah.
Especially when you're training it on multiple languages at the same time.
Uh-huh.
So,
I'm excited to dive into this. It
Yeah.
should be really interesting.
so DeepSeek LLM
Yes.
was developed by DeepSeek-AI.
That's right.
And it was a team of over 80 researchers that developed this.
Wow. Yeah.
Yeah,
That's a pretty big team.
that's a huge team.
Yeah.
And the models, they come in two different configurations,
Right.
7B and 67B parameters.
Mhm.
Pretty large,
Yeah.
making them some of the larger language models out there.
Definitely.
And the training data set itself is massive.
It is, yeah.
2 trillion tokens,
Wow.
primarily composed of Chinese and English text.
Oh, wow. So they're really going for the multilingual approach.
Yeah, they are.
That's pretty cool.
This is comparable to training on, like, millions of books.
Millions of books.
Yeah.
Wow.
Yeah.
That's a lot of data.
I mean, that scale is one of the key factors in its performance.
I bet.
So the architecture,
Yeah.
it's based on Llama,
Okay.
or a few important differences.
I see.
For instance,
Yeah.
the 67B parameter model uses something called grouped query attention,
Okay.
or GQA,
Right.
and it leverages this for greater efficiency.
Gotcha.
And what this does is it allows the model to process information more quickly
Okay.
with less computational overhead.
So it's like a more streamlined approach.
Exactly.
Yeah.
Now, DeepSeek actually offers some valuable insights
Okay.
into these ongoing debates surrounding scaling laws in AI.
Oh, interesting.
Can you elaborate a little bit about what they found?
Sure. So DeepSeek did a very meticulous analysis of hyperparameters like batch size and learning rate.
Gotcha.
And they analyzed these relative to compute budget.
Okay.
And by doing so, they actually they found some pretty valuable insights into optimal scaling strategies.
That's awesome.
Yeah, it is.
And so it sounds like they're finding that data quality plays a more significant role than we previously thought.
That's a great point. Yeah.
Yeah.
You're really picking up on a key takeaway here.
Awesome.
Their research suggests that data quality
Okay.
has a significant impact on how we should allocate resources when we're building these models.
I see.
When you have high-quality data, it actually favors larger models,
Okay.
even when you have the same total amount of data.
So it's not just about getting as much data as possible.
No, it's not.
It's about getting the right kind of data,
Yeah, exactly.
the good data.
Yeah, and this helps explain
Yeah.
why some of the past research that's been done on scaling laws
Right.
has had kind of mixed results.
Uh-huh.
Because some studies, they were saying increase the data size.
Okay.
Other studies said focus on model size.
I see.
The difference is likely due to the quality of the data they were using.
That makes a lot of sense.
Yeah, so it really offers valuable insight for, future AI development.
Absolutely.
Yeah.
So now let's talk about how DeepSeek actually performs
Right.
on benchmarks
Okay.
that are designed to assess their capabilities.
Sure.
So DeepSeek was tested
Mm-hmm.
on a bunch of these standard benchmarks
Okay.
for, language understanding, reasoning, math code generation, all these sorts of things.
Gotcha.
And the results are really quite impressive.
Oh, wow.
DeepSeek LLM actually surpasses LMMA 270B
Really?
in several areas,
Wow.
especially in code, math, and reasoning tasks.
That's impressive.
Yeah.
LMMA2 is a very strong model.
Yeah.
To beat it is no small feat.
It's even competitive with GPT 3.5 on certain creative tasks.
Wow. Competitive with GPT 3.5? That's a significant achievement.
That's huge, right?
Yeah.
Given what GPT 3.5 can do, I mean, that's a big deal.
That is a big deal.
And these results were achieved
Yeah.
through a rigorous held-out evaluation,
Okay.
meaning that the model was tested on data it'd never seen before.
Oh, wow.
So that gives you a more realistic measure of its ability to generalize
That's
to new information.
That makes sense.
I'm particularly interested
Yeah.
in these code and math benchmarks.
Okay.
Were there any particular highlights there
Oh, yeah, for sure.
that stood out?
DeepSeek was particularly good
Yeah.
at solving problems from leak code coding contests,
Oh, wow.
which are very competitive.
Yeah.
And they require a deep understanding of algorithms and data structures.
Right.
It also did really well on the Hungarian National High School exam,
Interesting.
specifically the math section.
Okay.
So this suggests that DeepSeek has a deeper level of understanding
Yeah.
than just regurgitating memorized information.
It's not just pattern matching.
Right, exactly.
Well,
it's understanding the concepts.
Yeah, it's understanding.
Yeah.
So those are very impressive results.
They are.
So far, we've talked about DeepSeek's scale, efficiency, and its performance across, all these tasks.
Yeah.
But now I want to talk about the chat version of DeepSeek, which is specifically designed for conversations.
Feels good.
How did they go about adapting the base model for this purpose?
So they used a two-stage process.
Okay.
The first stage was supervised fine-tuning, or SFT.
Gotcha.
Where they trained the model on a massive data set of 1.5 million instruction-based examples.
Okay.
And what this does is it teaches the model how humans ask for things.
So you're giving it a crash course in human communication.
Exactly.
That's cool.
It is.
And then what?
And then they did direct preference optimization, or DPO.
Okay.
And this technique uses human feedback to refine the model's responses.
So it makes them more helpful, relevant, and more aligned with user expectations.
And did they encounter any unexpected findings?
Yes.
During this whole alignment process?
There were a few, such as...
Interestingly enough, they found that the SFT process actually hurt the model's performance on certain tasks.
Oh, really?
Yeah, like sentence completion.
Interesting.
So their hypothesis is that those tasks might be better handled by pure language models without that conversational fine-tuning.
So it's like you're making it too specific to conversation,
right,
and then it loses some of its...
Yeah, it kind of over-specializes it.
Vulnerability.
Yeah, exactly.
That's fascinating.
It is.
It seems like even in our efforts to make AI more human-like, there are certain areas where the pure machine learning approach is superior.
You're right.
Yeah.
It highlights the complexity of language and, all the challenges that we have with teaching it to machines.
Let's dive deeper into these specific findings.
Particularly around data quality and scaling laws.
Sounds good.
And the next part of this deep dive.
I'm ready.
Awesome.
Let's do it.
All right. Okay, so let's unpack some of these fascinating insights around scaling laws. And, the influence of data quality. A little bit further.
Sounds good.
So DeepSeek's findings, they really kind of challenge certain assumptions about, the best way to scale these AI models.
Okay.
So there's this classic formula, C equals 6ND.
Right.
Where N represents the model parameters and D represents the number of tokens.
Yep.
And this has kind of been the cornerstone in determining the computational budget.
Yeah, it makes sense.
It makes sense on the surface, right?
Yeah.
Because it suggests there's this direct relationship between the computational budget and the size of the model and the data set.
Yeah, the more data, the more compute you need.
Right.
The bigger the model, the more compute you need.
But it seems like DeepSeek suggests that there's a more nuanced perspective here.
Definitely.
What is it?
So the team behind DeepSeek, they discovered that non-embedding FLOPs per token, which is represented as M, provides a more accurate representation of the model scale.
I see.
And this leads to more precise predictions.
Now, it's not just about the raw number of parameters.
No.
It's about the computational workload those parameters are handling.
Exactly. And using this new metric M, they were able to make a very crucial insight.
What's that?
That the optimal way to decide how big your model should be and how much data you should have is heavily influenced by the quality of your data.
The quality of data dictating the balance between model size and data volume.
Exactly.
That's huge.
It is.
Could you elaborate a little bit more
on
the interplay between data quality and model scale?
So think of it this way.
Okay.
A well-structured data set that's clean.
Relevant. It's like a concentrated source of information.
Like a good textbook.
Yes, exactly. Like a well-organized textbook versus
scattered notes.
Scattered notes, exactly.
Yeah.
And so what they found was that with this higher quality data, it becomes more advantageous to allocate a larger portion of your compute budget to scaling up the model size.
Interesting.
Rather than just increasing the data volume.
So if you have really good data, a larger, more sophisticated model is the way to go.
Precisely.
This is like a paradigm shift.
It is.
It's saying that data quality can actually influence the fundamental design of AI systems.
And it helps clarify why the past research has had such mixed results. Because some people were saying, you got to increase the data size. Other people said, focus on the model size.
Right.
The difference is likely due to the quality of the data.
That makes a lot of sense.
Yeah.
Yes, this finding really underscores the value
of DeepSeek's long-term approach.
It does.
Because they're very committed to continuous improvement and refinement of their data set.
Right.
Which could provide them with a significant advantage over time.
Absolutely.
And the fact that they meticulously document and analyze their methods just amplifies the value of these findings.
It does.
Because others can leverage this to optimize their own AI development strategies.
Exactly.
Now let's talk about their multilingual approach.
Okay.
Because they trained this on both Chinese and English data.
Yeah.
Which is pretty ambitious.
It is a very ambitious endeavor.
Did this lead to any noteworthy observations?
It did.
Okay, what were they?
So while the DeepSeek models performed very well on English benchmarks, they actually showed exceptional performance on tasks involving Chinese idioms.
Interesting. So they were even better at the Chinese.
Yes. It seems.
Does that suggest that training on multiple languages can actually enhance the model's overall understanding, even within a specific language?
It's possible.
It's like it develops this richer and more nuanced understanding by learning to perceive language from multiple perspectives.
Exactly. Like it's getting a broader view of what language can be.
This opens up a lot of possibilities.
It does.
For applications in translation, cross-cultural communication, content creation.
Yeah. The possibilities are really exciting.
Now, while DeepSeek does show a lot of promise, it's important to acknowledge some limitations.
Of course.
What are some of those?
So one of the limitations is that they can't update their knowledge in real time.
Okay.
They can only use the data that they were trained on, which only goes up to May 2023.
So they can't browse the web.
No.
They can't stay current with real-time information.
Right. They're kind of stuck in the past.
That's an important limitation.
It is, yeah.
What else?
They also acknowledge the possibility of generating inaccurate or misleading information, sometimes referred to as hallucinations.
Hallucinations.
Which is something that a lot of large language models struggle with.
And it can sound very convincing.
It can.
When they're hallucinating.
Right. It makes it difficult to distinguish between confident speculation and genuine knowledge.
What else?
And given that they primarily focused on Chinese and English, their performance in other languages is going to be more limited.
Makes sense.
Yeah.
Highlighting the need for, creating more diverse data sets.
Absolutely.
That encompass a wider range of languages and cultures.
Yeah. We need to keep pushing for more inclusivity.
Yeah, please.
So now that we've talked about some limitations, let's talk about some of the practical implications.
Okay.
Because the potential applications for these models are vast.
They are huge.
I mean, you could use DeepSeek to power multilingual customer support chatbots.
Personalized educational tools, creative writing assistant.
Oh, yeah.
Imagine having a creative writing assistant that could help you brainstorm ideas.
Yeah.
And generate different writing styles.
That would be awesome.
It would be amazing.
And the best part is,
yeah,
because they're committed to open source,
right,
all these capabilities can be accessed and built upon by anyone.
Exactly. It fosters greater inclusivity and innovation in the AI landscape.
Absolutely.
Yeah.
So now let's dive into the specifics of the alignment process, where they fine-tuned the model for those conversational abilities.
That's good.
All right, so let's revisit those two stages that were used to align DeepSeek for conversations.
Okay.
Remind me what those were again.
So the first stage was supervised fine-tuning, or SFT.
Right.
And they trained the model on a massive data set of 1.5 million instruction-based examples. And this process basically taught the model how humans phrase questions and give instructions. Okay, and then the second stage.
The second stage was direct preference optimization, or DPO,
right,
which used human feedback to refine the model's responses and ensure that they're helpful and relevant.
Gotcha. So you mentioned some pretty intriguing discoveries during this process, particularly about the impact of conversational fine-tuning on other language tasks.
Right. So one peculiar finding was that after SFT, the performance on tasks like sentence completion actually declined.
Oh, so it got worse.
Yeah, it seems counterintuitive, right?
Because you think if you're making it better at conversation,
you would think so.
It would be better at everything.
Right, but it actually got worse at sentence completion.
So what's the thinking there?
So their hypothesis is that tasks like sentence completion might be better handled by a pure language model.
Okay.
One that's not specifically tuned for conversations.
So for some things, you don't want it to be too specialized.
Exactly.
Interesting.
Yeah, and another challenge they encountered is that smaller models, particularly the 7B parameter model, exhibited a tendency for repetitive outputs.
After SFT.
Yeah, after SFT.
So how do they fix that?
They implemented a two-stage fine-tuning approach.
Okay.
So the first stage involved training on all the data, and then the second stage focused specifically on the conversational data.
Gotcha.
And this seemed to mitigate the repetition issue.
Without messing up the performance on other tasks.
Exactly.
That's awesome.
Yeah, it's a delicate balancing act.
Right. You got to make sure it can do the general stuff.
Right.
And be good at conversation.
Exactly.
Now, you mentioned some experiments with multiple choice questions.
Yes.
During this alignment process.
Yes.
Why did they do that?
So they incorporated a lot of multiple choice question data.
Okay.
Specifically, 20 million Chinese multiple choice questions.
Wow.
During the fine-tuning process.
Okay.
And this actually did lead to performance improvement on certain benchmarks.
Like what?
Like MMLU, CEVOL, and CMMLU.
Okay.
But these gains didn't really translate to other evaluation formats.
That weren't multiple choice.
That were multiple choice, right?
So it's like they over-specialized on multiple choice questions.
Exactly. It highlights the limitations of benchmark-driven development.
Right, because you're teaching it to the test.
You are.
But you don't really know if it's actually understanding.
Right. You're not fostering genuine learning.
Yeah.
You're just teaching it to pass a test.
Did they try using instruction data during the pre-training phase?
Yeah, they did.
And how did that go?
So they experimented with incorporating 5 million instruction data points, which were primarily multiple choice questions, into the final 10% of the pre-training phase.
Yeah.
The impact was negligible.
It didn't really do anything.
Yeah, it was very similar to the results that they observed when they added that data during the SFT stage.
So no real advantage there?
No, not really. And given that they decided to exclude multiple choice questions and the fact that they didn't have that much other instruction data available, they ultimately decided to skip that step.
Makes sense.
Yeah.
So now let's shift gears a little bit.
Okay.
And talk about the use of prompts in their testing.
Right.
Prompts are those initial instructions that set the context.
Yes, exactly.
For the conversation.
Yeah, they're like the guiding instructions for the model.
What specific prompts did they use?
So they adapted the prompt that was used by Lamé 2, which instructed the model to act as DeepSeek Chat. A helpful, respectful, and honest AI assistant. And they also emphasized safety, making sure that it doesn't generate any harmful or inappropriate content.
So they're baking in the ethical considerations right into the prompt itself.
Exactly.
Did they notice any variations in how the different models responded to these prompts?
They did.
What were they?
So the smaller models and the larger models reacted a little bit differently.
How so?
So introducing a prompt actually led to a slight decrease in the performance of the 7 billion parameter model.
Oh, really?
But it significantly improved the performance of the 67 billion parameter model.
So the bigger model was better at following instructions?
Yes. It seems that the larger models are better able to grasp the nuances and the intent behind the prompt.
Yeah, like they can really understand what you're asking them to do.
Exactly.
So this deep dive into DeepSeek LLM has been incredibly insightful.
It has.
Their rigorous approach to research, the meticulous analysis, and their commitment to transparency. It really sets a high bar.
It does.
For open source AI development.
I agree. Their findings are very valuable.
They challenge assumptions.
They do.
And give us all these new insights into optimal scaling strategies.
Yeah.
The role of data quality. And how to align these models for conversation.
It's really exciting work.
It is. And it underscores the importance of ongoing research.
Absolutely.
And collaboration in this field.
We need to keep pushing the boundaries.
Because this field is moving so fast.
It is.
While DeepSeek does show remarkable capabilities, we have to remember that this is an ongoing journey.
It is. There's still limitations to address, ethical considerations to navigate, and just a ton of potential applications.
So much to explore.
Yeah.
This work serves as a testament to the power of open source development and the value of long-term collaborative efforts.
We can achieve so much more when we work together.
Absolutely.
Yeah.
So thank you for joining us for this deep dive into DeepSeek LLM.
It was my pleasure.
Until next time, keep exploring, keep questioning, and keep diving deep.
I will.